what is resonance? A resonance, we need to understand, this is not an actual phenomena, this is a theoretical phenomena. So, why do we need resonance? Actually, there were certain molecules which were not being explained by a single Lewis dot structure. So, what we did is that we drew multiple structures of the same molecules. So, all those multiple structures theoretically possible or imaginary structures of the molecule which we draw to understand all properties are called resonating structures or contributing structures or canonical structures. So, resonance structures could be called as canonical structures or contributing structures. For that matter, if you take up benzene, alright. So, benzene possibly 6 pi electrons are delocalized. So, we cannot explain properties through that structure. So, what we did was we by our imagination we draw the possible structure. So, for benzene the most stable possible structures were like this, one was like this and another one was like this. So, these two structures for, but is it the actual benzene? No, this is not actual benzene. So, actual benzene was like this, actual benzene was like this is actual benzene. So, the actual benzene structure is called a resonance hybrid structure. This is called resonance hybrid structure. Your actual benzene is like this, actual benzene, alright. And the possible structures, because in this what this circle tells you that the pi electrons are delocalized. So, we are not able to understand the properties. So, either we can understand through this structure or that. So, these possible structures are called as resonating structures. These are called as resonating structures, or we can call them as canonical structures or contributing structures. So, actual molecule is represented by resonance hybrid, and the possible imaginary structures for a molecule we call them as canonical or resonating structures, alright. These are theoretical imaginary structures. So, resonance is a theoretical concept. Now, what is happening, just see this structure and this structure, resonance structure 1, resonating structure 2, they have same structure, same set of atoms, same formula, same number of electrons, same number of pi electrons. So, number of atoms, electrons, pi electrons, lone pairs is in totality is same. What is happening is the position of pi electron is changing. In two resonating structures, you can observe the position of pi bond is different, that is all. The position of all atoms is same, the formula is same in all resonating structures, alright. So, this is what you need to remember, that resonating structures, the formula will be same, the position of atoms will be same, only the thing that is changing is position of pi electrons and lone pair electrons involved in resonance, alright. So, this phenomena is called as resonance. And now, if you want to calculate resonance energy, what is resonance energy? Resonance energy is the energy difference between the most stable resonating structure and the actual structure, most stable resonating structure and the actual structure. And there is another way to find out resonating resonance energy value is experimental value of heat of formation minus calculated value of heat of formation. From that also you can calculate. Now, we have already discussed the characteristics, as in the bond length, bond lengths of bonds which are involved in resonance. For example, in this 1, 2, 3, 4, 5, 6, all these 6 bonds are equal in length. So, all the bonds which are participating in resonance, or I should say the atoms involved in formation of those bonds will have equal bond lengths if resonance is happening. Next point is resonance imparts excess, yes, of course it does. More the resonance, more will be stability. Greater is number of covalent bonds, more the number of covalent bond, more will be attraction, more will be stability. And always a neutral resonating structure is more stable than a charge. Greater the charge, less will be stability, and a neutral molecule is the most stable structure. And in charge, what you will remember, the first point is the structure having complete octet of atoms is more stable. Then you see that negative is on electronegative and positive on electropositive. Just remember these things in sequence. Sequence is very important. First check whether a molecule is neutral. If neutral, then that resonating structure is most stable. Then secondly, check if octet of all atoms is in complete or complete. If it is complete, octet is complete, it is more stable. Next, move on. If negative on negative, electronegative, and positive on electropositive, that will be more stable. And the last point is that opposite charges should be nearby and same charges far up. We want more attraction, less repulsion. That is it. And now we have few more resonating structures of given molecules, which you can observe. Only the position of lone pairs is getting changed over here or in these structures. So these are resonating structures of NO2, and these two are resonating structures of nitric oxide. So this is it.